Classical problems of synchronization. Classical highlight common challenges in coordinating access to shared resources among concurrent processes. Producer-consumer problem involves producers generating data and consumers consuming data from a shared buffer, requiring synchronization to prevent buffer overflows or underflows. Reader status problem deals with multiple readers and writers accessing shared data, balancing read access and write access while ensuring data consistency. Dining philosopher problem illustrates resource allocation and deadlock avoidance in a scenario where philosophers alternate between eating and thinking, requiring synchronization to prevent deadlock. Then, what is deadlock? System model. Deadlocks occur when process hold resource and wait indefinitely for additional resource held by other process, leading to system-wide resource unavailability. Processes. The system model include processes that compete for resources and may enter deadlock states if resource requests are not managed properly. Resources. Resources such as CPU time, memory, and I/O devices are essential for process execution and can become deadlocked when process hold them exclusively. Allocation matrices. Allocation matrix track resource allocation to process, highlighting potential conflicts and dependencies. Wait for graph. Wait for graph visualize resource allocation and process dependencies, identifying circular wait conditions that lead to deadlock. So this is deadlock. Resource 1, if it is needed by process 1, process 2 have to wait for resource 1. Resource 2, if it is needed for, if it is assigned to process 2, process 1 needs the same resource, mean it should be waiting for that resource. Deadlock characterization. Deadlocks are characterized by a set of necessary conditions that must hold simultaneously for a deadlock to occur. Mutual exclusion. Resources cannot be shared simultaneously but by multiple processes, reading exclusive access to prevent data corruption. Hold and wait. Process hold allocated resources while waiting for additional resources, creating potential resource contention and deadlock scenarios. No preemption. Resources cannot be forcibly taken from processes, leading to resource hoarding and deadlock risk. Circular wait. Process claims from circular dependencies where each process waits for a resource held by another process in the chain, causing deadlock. So, methods of handling deadlocks. Deadlock prevention. Prevention strategies aim to break one or more necessary conditions to eliminate deadlock occurrence. Techniques include resource allocation strategies such as ensuring resource hierarchy, avoiding circular wait, and using priority based resource allocation. So, methods for handling deadlocks. Deadlocks prevention. Prevention strategies aim to break one or more necessary conditions to eliminate deadlock occurrences. Techniques include resource allocation strategies such as ensuring resource hierarchy, avoiding circular wait, and using priority based resource allocation. Deadlock avoidance. Avoidance techniques use algorithms to dynamically allocate resources based on safe states, ensuring that process can progress without encountering deadlock. The banker's algorithm is a classical example of deadlock avoidance technique. Deadlock detection. Deadlock algorithms periodically check for deadlocks by analyzing resource allocation graph or using banker's algorithm. If deadlock is detected, corrective actions such as resource preemption or process termination are taken to resolve the deadlock. Recovery from deadlock. Recovery strategies involve restarting processes, rolling back transactions, or releasing resources to resolve deadlocks and restore system functionality, minimizing downtime and maintaining system stability. So these are all the methods which is used to handling deadlocks. So deadlock prevention, avoidance, detections, and recovery from deadlock. Finally, we got the recovery from deadlock. In this deadlock characterization, these are all used to these are all the things which have been the necessary conditions for happening the deadlock. So for that deadlock we have some methods to handling the deadlocks and recovery from deadlock. Thank you.